Okay, so welcome back to WSHS Algebra 1 Virtual Tutor. Today what we're going to learn is about GCF. You might have heard that acronym before, GCF, and GCF stands for Greatest Common Factor. So what we're doing is learning about how to find the greatest common factor amongst polynomials. You might have learned how to find them between two different numbers before, but now we're going to be including variables as well. So first thing we need to do is identify some vocabulary, and one of them is, of course, greatest common factor. And the greatest common factor is the largest number that all terms are divisible by. So this, in layman's terms, means that when you have more than one number, what's the highest number that both of them can be divided by without getting a decimal? So we want whole numbers when we're doing this. When we're including variables, when all the terms that we have in our expression or in our polynomial, when they all have a common variable, we also have to remove that. That's also considered a GCF. So the GCF will also include the variable with the lowest power. So it's kind of a little bit confusing because you think greatest would be the highest, but with variables, it's actually the lowest power that they all have in common. So we're looking for the highest coefficient that can be divisible by all of them and the lowest variable that can come out of all of them. So let's go ahead and try an example here. So when factoring and finding the GCF, what we want to do, our steps here, step one is first find the greatest common factor. Okay, so again, the highest number that can be divided by those coefficients or the constants and the lowest variable that they all have in common. Step two, once we find the GCF, we're going to actually take it out of the parentheses there, and then we're going to divide each term by that GCF that we just removed. When we're finished, we write our answer like this, where we have the GCF on the outside of the parentheses, and then after we do the division, whatever was left over goes inside of the parentheses here. Okay, so that'll make more sense once we start actually doing the math here. So let's go ahead. Example one, we have this 42x plus 16. It says find the GCF. So all they're asking you to do here is take out the greatest common factor. So what I want to do is, if I see these terms here, this coefficient of 42 and this constant of 60, I can choose any one of these to start breaking down and finding what numbers multiply to give me 42, or what numbers multiply to give me 60. So that is actually called a factor. So if I want to use 42, then I'm looking at all the numbers that multiply to give me 42. So what you want to do is get used to starting with 1. If you can't see it automatically, you want to start with 1 because you want to make sure you're not forgetting any pair here. So 1 times 42 gives you 42. If I go with 2 next, 2 times 21, that also multiplies to give you 42. 3 times 14 will multiply to give you 42. 4 doesn't work. 5 doesn't work. 6 works. 6 times 7 gives you 42 as well. So if you are forgetting what all these numbers are, because you might automatically know 1 and 42 and 6 and 7 when you were learning your multiplication tables back in elementary school. So 2 times 21 and 3 times 14 might not have come automatically to you. So what you want to do if you want to double check is, in your calculators, the trick to find the factors is to press y equals, and then whatever number you're looking for, like with 42, I would have put 42 up here. So you take the number divided by x, and then you press second graph. And when you press second graph, that's going to take you to a table. And the table will show you all of the factors. So it'll show 1 and 42, 2 and 21, 3 and 14, 6 and 7. So that's just a little trick just in case to make sure you're not forgetting any factor there. All right, so now that we've figured all of these out, what I want to do is see if 42 and 60 can be divided by any one of these factors here, because what we want to do is take the highest one that works for both. So obviously with 42, we can divide it by 42. Can you do 60 divided by 42? Well, no, you can't because you're going to get a decimal. So we don't want decimals, we want whole numbers. If I tried 60 divided by 21, that's not going to work either. Neither is 14 and neither is 7. But if I look here, 6 can definitely be divided. So we can do 60 divided by 6, and we can also do 42 divided by 6. So 6 would be considered the highest number that can be divisible by both terms here. So I want to go ahead and remove that GCF of 6. Okay, so the 6 is going to come out. And once we take the 6 out, we have to then write whatever's left over in parentheses. And by doing that, we would take each term here, the 42x and the 60, and we're going to divide it by 6 to see whatever is left over. And whatever's left over goes inside. So 42 divided by 6 would be 7. And we still have this x there. We can't cancel an x out or reduce that x in any way. So the 42x divided by 6 is actually 7x. So that has to stay there. And then we have 60, which is a positive number, right, plus 60. So positive 60 divided by 6 is positive 10. So we would write a plus 10 for positive 10. And that would be your answer. Now, what you want to also make sure is you want to double check in this parentheses here, with the 7 and the 10, do they have anything in common that can come out? And no, because 7 is only 1 times 7, and 1 or 7, well, 1 would work for 10, but there's nothing higher than 1 that would work. So we know we're finished. We could always go through and check our answer. And when we check our answer, if you see our answer here looks like we've created some sort of expression where we can actually do distributive property. So if you wanted to check your answer, you can always distribute back and see if you got it right. So if I did 6 times 7x, that is 42x here. And then 6 times 10 is 60. So I know I did a good job because I checked and I got 42x plus 60, which was my original problem here. Okay. Moving along, example 2, negative 24a minus 12. And what we want to do is factor this or find the GCF. So I notice here that this first term here is a negative. Actually, they're both negative. But more importantly, this first term, negative 24a, that's a negative. If we have a leading coefficient, meaning the one in front, and the leading coefficient is negative, what we want to do is remove the negative. Okay, so I want to make sure that after I'm writing my GCF, I've got to take a negative out. Okay, so again, I'm going to take any one of these numbers if I wanted to do 24. I want to find all the numbers that multiply to give me 24 and see which one is the highest that can be divisible by both 24 and 12. So 24 is 1 times 24, 2 times 12, 3 times 4, sorry, not 3 times 4, 3 times 8, and 4 times 6. So I can do 24 divided by 24, but I can't do 12 divided by 24, so that's out. I can do 24 divided by 12, and I can do 12 divided by 12. So 12 is actually the highest number that can be divisible by both 24 and 12. So 12 will be my GCF. So I'm going to take a 12 out. But again, because this leading coefficient was negative, we want to actually remove the negative. So instead of it just being a positive 12 as my GCF, I'm going to make it a negative 12. So now I need to figure out what's left in the parentheses. So I take my original expression here, negative 24a minus 12, and I'm going to divide it by the GCF that I just found, which is negative 12. Okay, so negative 24a divided by negative 12. Well, a negative divided by negative is a positive, so this would give me a positive 2a. We have to include that a because there was an a there. We can't cancel the a out. Next part, we have negative 12 divided by negative 12. And again, negative divided by negative is positive. And so that would be a plus 1 in there. 12 divided by 12 is 1. So this is my answer. And again, if I wanted to check, I can check. Negative 12 times 2a is negative 24a, and negative 12 times positive 1 is negative 12. So you know you did a good job if you can check and get your original expression back. Okay, we're going to try another one. Example 3. This time, if you notice, all three terms here have some variables, right? So if they all have a variable, there's a possibility that we can actually remove a variable here. So I want to try with I'm going to start with my coefficients first, the 40, 48, or 8. My leading coefficient, this 40, is not negative, so I don't have to worry about removing a negative. So I'm going to take the number 40, or you can choose any one of these coefficients here to start. If I chose 40, what numbers multiply to give you 40? 1 times 40, 2 times 20, 4 times 10, 5 times 8. Okay, so which one of these numbers will work that can also be divisible by 40, 48, and 8? Well, 40 is not going to work. 20 is not going to work. 10 is not going to work. 8 will work. You can do 40 divided by 8, you can do 48 divided by 8, and you can do 8 divided by 8. So 8 will be the numeric portion of the coefficient of my GCF. So I can go ahead and remove an 8 so far. Now I want to look at these variables here. I see that the first term has an a, the second term has an a, and the third term has an a. Okay, so my first term actually has an a to the second power, an a squared. My second term has just a single a, and my third term has just a single a. So if I'm looking here, I had an a squared, an a, and an a. When you're removing a variable GCF, what you're doing is taking the smallest, the one with the smallest power, the lowest power. So if you see a variable that's just standing alone, our power is actually 1, right? So the lowest power here would be a to the first power, or just a single a. So this means that I can actually remove an a. And I can only do that because all three of these terms had an a. If I look at the other variable that's there, I also have b's and I have a c. But if you look, not all three terms do not have a b. And all three terms do not have a c. So because of that, I can't remove a b and I can't remove a c. The only one that I can remove is the one that they all have in common, which would be the a. So that means my GCF is actually 8a. So what I would do is figure out next what would be left in parentheses. So I'm going to divide each term here by 8a. So when you're dividing monomials here, remember you divide your coefficients. So this would be 40 divided by 8, which is 5. And then we subtract exponents. So if I have two a's on the top and one a on the bottom, well, 2 minus 1 is 1, right? So there's going to be one a left. And the b's, I don't have another b to subtract exponents or cancel out. So I'm going to still have a b left over. Then the next part, 48, or positive 48 divided by 8 would be a positive 6. And if I have an a in the numerator, a in the denominator, that's a to the first, so a to the 1 minus 1, which is 0. So that means there are 0 a's left. So my a's would actually have canceled out here. But I do have b to the fourth power left over because I can't do anything with that. So that'll be 6b to the fourth in the middle. And then finally, negative 8 divided by 8 is a negative 1. And then my a's, again, these a's are going to cancel out because you have 1 up here, 1 down here. 1 minus 1 is 0, so there are 0 a's left. And then you still have that c that was there, so this will be minus 1c. Now, typically, we don't see this 1 right here. That's like an invisible 1. When we see it as like a multiple choice or whatnot. So I can also write my final answer as 8a parentheses 5ab plus 6b to the fourth minus c. Because whenever there's a 1 in front, typically that's invisible. Okay, last example here. We have 12x squared minus 18xy squared minus 36y. So again, we have not only coefficients here, but we also have some variables. We might be able to remove one. My leading coefficient is not negative, so I don't have to worry about taking a negative out. So I'm going to go ahead and break down the 12 to see what would the GCF be for 12, 18, and 36. So 1 times 12 is 12, 2 times 6, and 3 times 4. 12 will not work because I can't do 18 divided by 12. So 12 is out. 6. Can 6 work for all three of them? I can do 12 divided by 6, I can do 18 divided by 6, and I can do 36 divided by 6. So this does work. 6 would be my GCF so far. So I'm going to remove a 6. Then I see that they all have variables. Do they all have an x? The first term has an x, second term has an x. The third term does not have an x, so I cannot remove an x from here. What about the y's? Well, the first term doesn't have a y, so I can't even remove a y. So there is actually no variable here that can come out, just the number 6. That's it. So make sure you're careful with that. Again, in order to remove a variable, they all have to have that same variable. So this means that if the only GCF I have is 6, then I go ahead and follow the next step. I'm going to divide each term by 6 to see what's left in parentheses here. So 12x squared divided by 6, well, 12 divided by 6 is 2, and we're going to have the x squared left over because we can't cancel it out. There was no other x that we could have divided by. Negative 18 divided by 6 is negative 3 or minus 3, and we'll still have the xy squared left over. And then negative 36 divided by 6 is negative 6, and we would have the y left over. So this will be my final answer. Okay, I'm going to go ahead and do one more. I'm going to do one where we can actually take the variable out and there's no variables left. All right, so if we look at the practice problem number 3 here. Number 3's got a lot going on here. First of all, I see that my leading coefficient is a negative. So this means when I find the GCF, I'm actually going to also take out a negative. Okay? And then I also notice that they all have the same variable k. So that means a k should be able to come out. But let's go ahead and figure this out. So if I have 8, 24, and 6, let's say I want to break down the 8 and see if any of these numbers would work for all three of them. So 8 is 1 times 8 and 2 times 4. I can do 8 divided by 8. I can do 24 divided by 8, but I cannot do 6 divided by 8. So 8 has to be removed here, or has to come out. It's eliminated. Then I have 8 divided by 4. That works. 24 divided by 4, but 6 divided by 4 does not work, so we can't use a 4. So that means 2 is going to be the highest, or the GCF here. They're all even numbers, so 2 will definitely work. But you can't assume that just because they're even that 2 would be the GCF. You always got to make sure you're checking for others. So we're going to remove a 2. And more importantly, because this leading coefficient was negative, we're going to actually make that a negative 2. Then I also see, again, like I said, they all have a k, right? This first term has k to the third, second term has k squared, third term has just a single k. So with the variables, we are removing the lowest, the one with the lowest power, and the one with the lowest power would be just the k by itself. So we can take out negative 2k as my GCF. Then I'm going to take each term and divide it by negative 2k to see what would be left over in my parentheses. So negative 8 divided by negative 2 is actually a positive 4. And if I have 3 k's in my numerator, 1 k in my denominator, well, 3 minus 1 is 2. So I would have k squared left over, k to the second power. Then negative 24 divided by negative 2 is a positive 12. And if I have 2 k's in my numerator, 1 k in my denominator, well, 2 minus 1 is 1. So I will have 1 k left. And then a positive 6 divided by negative 2 is actually a negative 3. And my k's will actually cancel out because I have 1 k in the numerator, 1 k in the denominator, 1 minus 1 is 0, so I have 0 k's left. So I wouldn't write a k there. So this would be my final answer. Okay, and that's it for finding your GCF with polynomials.